All right, let's get right into it. We've all seen these mind-blowing demos of AI assistants that can literally take over your computer. Clicking, typing, navigating websites, just like a person would. But how? How do they really work? Well, today we're going to pop the hood and unbox the core technology that makes this whole generation of AI possible.
It all starts with a problem that I think every single one of us can relate to. Who actually enjoys those tedious, soul-crushing tasks that just eat up the day? I mean, finding receipts in your email? Ugh. This is exactly why these new AI agents are so incredibly exciting. They promise a future where we can just tell our computer to do something and it just gets it done.
So what is the big leap forward here? Well, for years, automation relied on something called APIs. You can think of them like these rigid, pre-built bridges between different apps. The problem? If an app's design changed even a little bit, that bridge would just break. The whole thing was super brittle. This new way is totally different. These AI agents learn to navigate apps visually, just like you and I do, which makes them way more flexible and, honestly, way more powerful.
To really understand how they pull this off, we have to start with the most basic, fundamental challenge of all. You have to teach the AI how to see.
I mean, it sounds like a ridiculously obvious question, right? But it's actually a massive technical hurdle. If an AI can't actually perceive the visual layout of a website or an app, where the buttons are, where the text is, then it has no hope of interacting with it in a useful way.
See, the large language models we're all used to, like the earlier versions of GPT, were text only. They couldn't look at a screenshot to save their lives. People tried these clunky workarounds like feeding them the raw HTML code of a web page, but that was just a total mess. It didn't capture how a page actually looks and feels to a person.
And that's where the solution came in. Multimodal models. Think of models like GPT-4. These are the AIs that can basically see and read at the exact same time. They can take your text command, look at a screenshot of your screen, and understand both of them together, in context. All of a sudden, the AI wasn't blind anymore. And this was the first, absolutely crucial piece of the puzzle.
Okay, so the AI can see the screen. Awesome. But how does it go from just seeing to actually doing? How does it translate a simple command like click that button into a real mouse click? Well, this next challenge has a name. It's called grounding, and it's all about connecting an abstract idea from language to a concrete, specific spot on the screen. The AI might understand the concept of a Walmart button, but it needs to know precisely which group of pixels is that button so it can actually click on it. So researchers came up with this really clever hack to solve this. One popular technique is to basically overlay a grid on the screen. The system programmatically draws these little numbered boxes around everything that's clickable. Then the AI doesn't just say click the button. Instead, it says click button 17. The computer knows exactly where box 17 is, moves the mouse, and boom, problem solved. Now, while those numbered boxes are a clever trick, the big players like OpenAI take it a step further. They use a process called fine-tuning. This is basically specialized training to teach the AI to predict the action directly without needing any of those numbered boxes. This makes the agents way faster and a whole lot more reliable.
And that brings us to the real secret sauce, the training process that gives these AI agents their spooky, almost human-like abilities. It's a really powerful two-step combo.
What's so cool is that the process is a lot like how we learn. First, you have imitation learning. The AI literally just watches thousands of videos of people using computers and learns to copy their actions. And then comes reinforcement learning. This is where the AI is set loose to try completing tasks on its own, learning from good old-fashioned trial and error. And this table really breaks down the difference perfectly. Imitation learning is like going to school. It provides the foundation, it teaches the AI what a button looks like, and that clicking it is probably more important than clicking on some random empty space on the page. But reinforcement learning, that's like getting real-world experience. It's where the true power comes from. It teaches the AI how to be resilient, how to fix its own mistakes, and how to deal with stuff it's never seen before. And this right here is the game changer. This is what lets an agent handle the messy, unpredictable reality of the internet. So when a random cookie pop-up appears, it hasn't been explicitly programmed for that specific pop-up. But through reinforcement learning, it figures out, oh, I should probably dismiss this and get back to what I was doing. It actually learns how to problem solve.
Okay, so let's zoom out to the bigger picture and talk about how this all becomes a safe, usable product. Because let's be honest, letting an AI have total control of your computer, well, that raises some pretty important questions, doesn't it? What's so smart is that safety isn't just some hard-coded rule, it's actually a learned behavior. Using that same reinforcement learning system, they teach the AI to recognize sensitive screens, like a credit card checkout page. It then gets a positive reward, a little treat basically, for pausing and asking you for permission, and it gets a negative reward, a penalty, if it dares to proceed on its own. It literally learns to be cautious.
You know, what's really wild is how this tech is already spreading. While the huge companies are building these agents from scratch, the open source world is showing that you can get shockingly good results just by giving a powerful base model like GPT-4 a very, very detailed set of instructions, what the pros call clever prompting.
And that leads us to this really powerful final thought. The fact that models that already exist can do so much, well, it suggests that the technology might be way ahead of our ideas for it. Maybe the real limit right now isn't what the AI can do, but what we can imagine asking it to do.
So that brings it all back around to you. If you had an assistant that could learn to do pretty much any task on a computer, what's the first boring, repetitive, battery-draining thing you would hand over? The possibilities, as they say, are just starting to open up.